This is Robert, and in this video we're going to convert our list, which has been implemented using a struct, into an object. So we're going to make list an object. In C++, anything that we can do with a class we can also do with a struct. The only difference between a struct and a class in C++ is that the members of a struct are public by default, but the members of a class are private by default. So in the third video in this series, this is the second video in the series, we will take a look at the labels, public and private. So that'll be in our third video. We're also going to implement our project here using multiple source files and a header file, but we'll save that for the third video. Okay, so we have two members of our list struct right there, and in order to make this an object we need to encapsulate not only the properties, the variables here. They're called properties when we're talking about objects. We also need to encapsulate the methods, and methods are also called member functions. Right now the list is implemented using standalone functions. All I have to do to make them member functions is move those prototypes inside of the struct. So I'll just grab them and I'll move them into the struct. Okay. Now the prototypes are inside of the list struct, so they're now considered member functions. So I'll just label them as member functions. Okay. When we have a member function, this member function has access to all of the other items inside of the object. And so if we take a look at our standalone function prototype, we are passing the list to a member of itself. So this kind of notation doesn't make any sense anymore because we're going to be using dot notation to get to add an item. In our previous implementation, we had add an item and then we passed the groceries list that we created in main. But now we are going to be using dot notation, and we're going to be calling add an item and print the list, which are both members of a list object. So we have to change to dot notation, which means we have to specify groceries dot add an item. Okay, so I'll put groceries here, dot add an item. And as we said, it doesn't make any sense to pass the object to itself, its own member method, or member function. So we can go ahead and just get rid of that, that single argument right there. So let's go back up to our prototype, and we'll just go ahead and remove it from there also. Okay, we're going to be doing the same thing with print the list. It doesn't make any sense to pass the object to itself, so we just get rid of the argument there. And if we want to print the groceries list, we say groceries dot print the list. So now our method calls match our method prototypes, and notice that the prototypes are now inside of the list struct. Okay, we're almost done. We just have to do a couple more things, which is we have to update the function definitions or method definitions. These are now part of the list struct, which means that the header, for the header of the functions, we have to specify that these are inside of the list object. So let's go down to the headers of those two functions. And we will specify that these two functions are inside of the list. And the two colons right there specify that the scope of add an item is inside of list. So the two colons, that is the scope resolution operator. Okay, and then we'll get rid of our argument here, our formal parameter, and we'll get rid of our formal parameter here. Okay, as soon as I did that, I got lots of new errors. And remember that since this is now a member method, these are both member functions, I don't have to specify anything special about item count or items or anything like that. I got rid of our arguments, and all of these errors popped up because I got rid of the argument which is called the list. So what I have to do is I just have to get rid of the reference to the argument and just use item count by itself. Same with items. So I'm just going to get rid of the argument right there and right there, and looks like two more lines. Okay, so I am accessing items and item count directly, because remember that this is now a method or member function, and member functions can access the other items inside of the object directly. So add an item can directly access items, and it can directly access item count. How does C++ know which object to access? C++ knows it based on the method call. And so we're using dot notation here. And so we're specifying groceries dot add an item. And so here's our object, groceries. And so when we say groceries dot add an item, we are dealing with items and item count from within groceries. So that's how a method call works using dot notation right there. Okay, so we have fixed add an item. Let's go ahead and update print the list as well. So I'll put list and the scope resolution operator. And we already got rid of our argument there, so I'll go ahead and directly access the items from the object, which means I get rid of our previous formal parameter right there. And it looks like that's about it. So we don't have any errors. I'll go ahead and build it and see if we have a buildable solution. The build did succeed, so this project would run. Let's go ahead and recap what we did though. So now I have a member function called print the list, and I can see that it is part of the list object. I also have add an item, which is also part of the list object. I updated the function calls here, so now they are method calls, and so that's the only change that we had to make to main. And then we just move the prototypes inside of the list object, and that's about all there is to it. There's a couple more things to consider here though. Notice that we still have to set the item count equal to 0, and that's being done outside of the list object. There's a concept here called encapsulation. And what we want to do is we want to make our list object self-enclosed, which is called encapsulation. We want everything that deals with list to be part of list. We still have one statement right here that is not part of list. The reason why we can't do that inside of the list right here, in other words, the reason why we can't initialize it is because this is a struct definition. And so technically there's no executable code inside of the struct definition. So most languages will not allow me to initialize the members of an object. So it has to be done either outside an executable code or it has to be done inside of a constructor. So in the third video, we're going to see what we get if I change the word struct to class, and we're going to see why we get several new errors right there. And then we're also going to figure out how to make this encapsulated inside of our new object as well. Okay, see you in the third video.